Okay, good morning, everybody. I hope you guys are doing well. Hopefully, those practice problems weren't too tricky for you. Today, we're going to talk about subtracting polynomials. This is very, very similar to the adding polynomials. The only difference is we're subtracting. Now, with that subtraction, though, comes one additional step that we need to talk about. So let's take a look at the first example that's already done for us. If you look at this, we have this polynomial right here I underlined in red, and then that is being subtracted by this. Now, what makes this tricky is this minus sign right here. Now, when that's a plus, you can just drop all the parentheses. They don't matter anymore, okay? But when this right here is a negative sign, this negative has to distribute to every single term inside the second set of parentheses. So looking down here where we have this negative, if you notice, this negative went to this 4, it went to this -5, and it went to the 3. So the 4 was originally positive. Now, if you notice, once we distribute a negative, -1 times 4 is -4. Now, when I do -1 times -5, I get +5. And when I do -1 times 3, I get -3. So you can see, as I showed you right up here, that negative has to distribute to everything first. Once it distributes to everything, you end up with a plus right here, and you can just drop you can drop your parentheses and group your like terms together, exactly what we were doing before. So if you look here, here's an x squared term, there's an x squared, and then we move on to the x term and x term, and then the last one is the 3 and the 5, which are your constants, and you can see then the constants are grouped, the x terms are grouped, and then the x squared terms are grouped right there, and then we add the like terms together. So again, the only difference between the addition and subtraction is the subtraction, you've got to distribute that negative to everything in the second set of parentheses. So let's try a couple problems on our own here. We have two of these to try, and then we're going to try a perimeter problem. Okay, so subtracting the polynomials. So what did we just get done saying? I said that if you have subtraction, which if you look right there, there is, that negative has to distribute to the -2, to that +1, and to that -2. And so once I distribute it to everything, I don't actually even need parentheses anymore. So I'm going to write this as 4x to the third minus 3x squared, so I'm just copying the first equation, plus 6x minus 4, and then this negative times a -2 becomes a positive 2x to the third, and then minus x squared, because -1 times +1 is -1, and then -1 times -2 is positive 2. So as I said, this negative right here, I'm circling it over and over again, gets distributed to each one of the terms in the second set of parentheses. Okay, so once I do that, once I distribute that negative to everything, we can start looking for our like terms. And I'm going to go through and underline them. So here's an x to the third, there's an x to the third. Then we're going to go to here's my x to the second, there's my x to the second. Here is my x, and looks like there is no x in the second one, which is okay. And then the last one is we have our constant right here and our constant right here. So now let's group our terms together. We'll start with the red ones. We have 4x to the third, and we have a positive 2x to the third. That gives us 6x to the third. Now looking at the purple, we have a -3x squared, and then we have a -1x squared. So -3 plus -1 is -4x squared. Moving on, oops, nope, I did it right. Then moving on to the kind of off yellow color, there's only one of those. So we just write plus 6x. And then what do we got? Just the blue left, I think. We have negative 4 plus 2, which is negative 2. And there you go. There's your answer right there. 6x to the third minus 4x squared plus 6x minus 2. And that is a polynomial that is in standard form. All right. The next one, same as the last one. It's a subtraction problem. The first thing we're going to do, we're going to take this negative right here, and we are going to distribute this negative right here to the 7, to the negative 1, and to the 12. And so when I write out, the first terms aren't going to change. 8y minus 10 plus 5y squared. And then negative 1 times 7 is negative 7. Negative 1 times negative y to the third is y to the third. And negative 1 times 12 is negative 12y. Now moving through this expression that we have, we want to find the highest degree, which it looks like it's y to the third. Now there's only one of those. It's fine. Let's move on to a different color. Let's go to blue. Here's a y squared. Looks like there's only one of those as well, which is, again, that's fine. Now we want to go to the y's. There's a y and there's a y. And then the last one, we'll go down to this purple, is my constant right there and constant right there. Okay, so we've got them categorized. Now we just need to organize them. We're going to start with the highest degree, which is y to the third. And then we're going to have plus 5y to the second. Again, I like to cross them off as I'm using them so we don't forget anything. And then we have plus 8y minus 12y plus 8y minus 12y. And then we still have a minus 10, which is right there. And then we have a minus 7, which is right there. And so we have them organized. And now we just need to add the like terms up. Be careful with this. There is only one y to the third, so we leave that one alone. There is only one y to the second, so we leave that one alone. These two, the next two, the 8y minus 12y, those can be combined. That turns into minus 4y. And then we have negative 10 minus 7, which is negative 17. And there is your final answer. All right, guys, we're almost done. We got one more to go here. The last one that we're going to discuss today is how to find the perimeter. I guess there's two of them. How to find the perimeter of this expression. So you can see this is a triangle, and there are expressions written for each length. So when they ask you to find the perimeter, that means to add up all of the sides. So we need to write an expression for this. So we're going to take this 4x minus 8 and this 3 minus 2x and this 11 plus y. We're going to take those three and we are going to add all of those up. So let's do it. 4x minus 8 plus 3 minus 2x plus 11 plus y. So looking through at my like terms, I'm going to go a little quicker on this one. You can see there's 4x and 2x. And then there is a y. There's only one of those. And then there is a negative 8, a 3, and 11. So what we got to do is add up all the like terms. So let's start with the x's. So 4x minus 2x. So we have 4x minus 2x plus y minus 8 plus 3 plus 11. So these two are like terms and these three are like terms. And then the y is kind of its own thing. So 4x minus 2x is 2x. Then we have plus y. And then we have the minus 8 plus 3 is -5, and -5 plus 11 is 6. There's your expression. All right, I know I said that was the last one. I apologize. We got one more, then we'll have it. So this said find the perimeter. Now remember, perimeter is the sum of all of the sides. Now this is a rectangle. My son has been talking, one of my four sons has been talking a lot about rectangles and polynomials lately in his class. And so one thing to keep in mind about a rectangle is if you know one side, the 5, if you know this one side, which is 5x squared minus 4, you know that that also applies to that side. And the same with this 7. 7 plus 6x also applies to that side with rectangles. So what you need to remember is there's actually two of those 5x squareds minus 4s that are being added up. So there's 5x squared minus 4, and then plus 5x squared minus 4, because there's one here, and then there's this side right here that needs to be accounted for. Same thing with the 7 plus 6x. So it's plus 7 plus 6x plus 7 plus 6x. So there's a lot of stuff going on here. Let's get our underliner out here. Here's an x squared. Here's an x squared. Here is an x term and an x term. And let's go with purple. There's a constant, 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 and constant. There are a lot of stuff going on. So let's rewrite this so it makes a little more sense. Start with the red, 5x squared. Then we have another one of those, plus 5x squared. So we got this one and we got this one. Now we're going to go on to the plus 6x, plus 6x. Got those. And now we just have all the numbers left. Minus 4, minus 4, plus 7. Hope I don't run out of room. Just made it. Okay. Sorry, it's sloppy, guys. I'm trying to write on an iPad. It's not that easy. All right, 5x squared plus 5x squared is 10x squared. Got those two added. Add those up. Plus 12x. And then we have negative 4, which is -8. -8 plus 7 is -1, and -1 plus 7 is 6. So there is your expression for the perimeter. Okay, guys, that does it. Thanks for listening. I hope you guys are all doing well, and I will talk to you soon. Take care.